Good morning, everyone.
Good morning.
How are you all today?
I'm fine, thank you.
Good. Good. So we're going to start here in just a couple minutes. I'm going to let a few more people show up, and then we'll get started. Okay. I was just checking my son's grades in his in high school. See how he's doing. Anybody have any nice plans for their weekend?
Not really the same thing.
Yeah.
Okay.
Unfortunately, I have plans, but I don't know what I'm going to do. We'll see.
We're expecting a lot of rain. I also have tree work being done in the house next door, so I'm going to stay muted because I don't know how loud it's about to get, but I feel like it could get loud.
How fun. All right, so we'll give a couple more minutes. Just to give maybe one more minute to give people a chance to get here, get logged in. So we're getting a few more people.
All right, it looks like Yelda asked a question in the chat box about asking questions throughout the webinar. Kate is going to go over just how she wants the webinar to kind of flow and how she wants you guys to ask questions, but in general, it will be open to questions. So you guys are all unmuted if you choose to be so, and you can just ask your question and she'll hop right in and answer it for you.
All right, well, why don't we go ahead and get started. So I'd like to welcome everyone to the to a webinar. This is a StatPREP webinar. We're going to be discussing 2Sample-T little app and a few other little apps today. For now, let's figure out how to get to where I am. Okay, so we are recording this webinar just so that we can watch it in the future. It actually is recording right now. We do retain the right to show it in the future, and I'll be posting it on the StatPREP website so you can come back and watch it. All right, just a couple guidelines about it. So I am actually, I like the idea of you asking questions while we're going through it, so please ask questions. If you're not going to ask a question, if you could mute your mic, that way we don't have background noise doing it. If you prefer to ask it in the chat, you can certainly ask questions in the chat. Then we have a moderator that will be monitoring the chat window and letting me know if there's a question, but you're more than welcome to just ask your question. Just let me know if you want to ask a question. There is going to be a survey at the end of the webinar, and we really appreciate you answering that and giving us some feedback. So again, we're going to be talking about the 2Sample-T little app and a few other little apps. My name is Kate Kozak. I am from Coconino Community College and in Flagstaff, Arizona. And so again, my name's Kate. I'm also on the StatPREP leadership team. So that's where I've got involved in this. Devaney Brown from MAA is our moderator. And if you could just introduce yourself, giving your name and what college you're from, that would be wonderful.
Okay, Mehdi Hakim Hashemi from Normandale in Minnesota. Should I write this down?
Yep. So
Okay.
anybody else want to introduce yourselves?
I'm Jennifer Appleby from Middlesex County College in New Jersey.
Wonderful. Cheryl Howell from Howard Community College. Anyone else? All right, well, again, just let me know if you have questions. If you have a question, if you could let me know who you are, that'd be wonderful. All right, so just to give you an idea of what we're going to be doing today, we will again first be looking at the 2Sample-T little app and how you could use it in your class. We'll then look at proportion testing using the little app. And then we will be looking at how you might be able to assess you in your classes using these little apps. And then if we have time, we're going to talk about sampling and resampling tutorials that exist. If we don't have time, they do exist, and I'll show you where you can find them if you want to learn more about sampling and resampling. All right, so let's start off with the 2Sample-T little app. The first thing is we are going to go to the StatPREP website. So that is just statprep.org. I'm going to go ahead and go there to just show you how this works. So this is the StatPREP website. This is our main page of this. This is the home page. We also have the hubs listed here. So if you want to go into one of the hubs, you can find out more information about the hub and what the dates are for those. The webinar series, we do post all of the webinars in the webinar series tab so that you can go back and watch previous webinars. If you want to apply to go to a workshop, if you haven't applied for next year's workshops, you can click on this to go there. We have newsletters that we're putting out, and we will be posting those newsletters here on the website. And there's some information about us if you want to know a little bit more about StatPREP, the StatPREP team, and MAAs contributing to that. That'd be wonderful. And then under resources is actually where we want to go. So we're going to go into resources. There are little apps, which is what we're going to start talking about. There's also class lessons that you can actually use in your classes too. Tutorials are really for you, though I actually just used one of the tutorials yesterday in my class. And then we do have some data set suggestions if you want to look and see some places where you can get some data sets to use in your classes. And workshop and hub leaders information there. So we're going to go into the little apps. And we have lots of different little apps in here that you can use in your classes. We're going to do the 2Sample-T. So I'm just going to click on the picture that looks right under 2Sample-T, and we'll get into that little app. All right, so let me go real fast back to my webinar because I want to just go to the next page. All right, so back to where we were. Whoops, where am I now? I'm going to do this, but I'll go back and do it. So this is the little app that we're going to use. There's different response variables here that we can work with. There's different explanatory variables that we can also pick. Covariates, we're not going to be needing them in the T statistic, but they're available if you want to look at them. And then we can also change the sampling size. And we can do a stratified sample if you'd rather do that. We're not going to do that today, but you can. This is actually a graphic, which is just a dot plot of whatever response variable and explanatory variable we pick. Right now, they're kind of boring. We'll pick some new ones in a couple minutes. There's an explanation that kind of talks about what's going on here. That gives you a little bit of idea of what's happening. Another tab is a code book. Every R package has a code book with it that describes kind of what the data is. So this is actually the data set, the NHANES data set that was collected by the U.S. National Center for Health Statistics. And we've got many different years in here. And it just gives you an idea of what the variables are and what the survey is. So right now, the variables we've picked are ID and survey year. That's not the variables we're going to be doing here in a couple minutes. And then we also have another tab that tells you the R commands that we're using. So if you want to be able to use this in your class and be able to change the R commands, you can do that. So we're going to go back to our graphics. And we're going to just pick a different variable. I actually think a good variable to pick from, there's lots of them. There's ID, age, age in months. There's HH, income median. There's poverty. There's number of rooms in your home. There's weight. And again, if you don't know what some of these are, we can click on them and then go into the code book to see what they are. I would like to look at poverty. And I would like to look at poverty in terms of an explanatory variable. And the variable I was thinking of using, I can do survey year, which isn't very interesting, gender, home ownership, work, diabetes, little interest. Again, we can go look to see what that means. Depressed, sleep trouble, physical active, alcohol, all these different explanatory variables that could be there. Some that might be more interesting to your students. So a lot of times I let my students pick them. Sometimes I don't. And today I'm actually going to pick for us. So I'm going to actually look at diabetes and how diabetes and poverty kind of relate to each other. So this is the scatter plot. It actually is a jitter plot, which just means instead of putting all the dots together on the line together, we kind of move them off the main line here. So this person, this value right here is one person's data value, and it actually is just the same as this person's data value. They just moved off so you don't see all the dots together. And so we have no, they don't have diabetes in this column, and yes, they do have diabetes in this column, and we're looking to see what the poverty level might look like. Again, we can go into the explanation to see kind of more about what's going on and how did we do this. So this gives you a little bit of an explanation of what actually is happening and what you can do. So if you can't remember what to do, this is a good place to go. The code book now tells us what poverty is, and it's a ratio of family income to poverty guidelines. Small numbers indicate more poverty, bigger numbers indicate less poverty. And then they also are told whether or not they have diabetes or not. So that's what the code book tells us. And again, you can go to the ARC commands and see what commands you would be using in your program. Just make sure that if you do that, your package you have on our ggplot package is on. You also need the enhance package on if you go into RStudio so that you can use this data set. All right, so now let's talk about what I would do with my class. I'd be showing them this. I'd do that same explanation I just did. And then maybe I want to see if there's a difference between people who have diabetes or not diabetes based on their poverty. So is poverty actually an indication of whether somebody has diabetes or not? So it might be interesting to actually see what the centers are. So I might show the means. And I can see from this sample that this mean for the no group is a little bit higher than this mean for the yes group. So remember, lower poverty means that they are have more poverty. So people who have diabetes seem to have a lower mean poverty level than people who don't. But we can also maybe say, take another sample. So we could say, okay, this sample shows that. Let's take another sample. And this sample shows even more of a difference between these two means. And you can keep taking different samples and showing that. And I would ask you, what do you think when we see these samples? Do we see a difference? And then you can also, if you wanted to, you can show how sample size can affect things. So, whoops, sometimes this happens, you just have to reload. So I was doing poverty and diabetes. And I might want to pick a sample size of 20, and you can actually really see what you have. Now, this isn't going to give us great information because we only have 2 or 3 dots on this yes group and a whole bunch more in the no group. So that shows you what the sample size can do. So maybe we'll go back to maybe even a larger sample. Let's go to 200. And now we can see, oh, if I get a 200 sample, 200 data values, I don't get much difference between these, at least with this sample. And I can take a different sample, and now I can see more of a difference. So it is a way for me to say to you that, hey, there is a difference between these kind of calculations and how there is a difference between them or there's not. So we can keep looking at this. I'm going to go back to my 100. I like 100 as a sample size. And I'm going to see, hey, that looks like in this sample that there is a difference between these means. We can actually look at the confidence intervals between these two. And here's my confidence interval. And now I can see, oh, these confidence intervals actually do look like they overlap a little bit. So what would that say to you if they overlap a little bit? And I like to ask questions and try to get people to answer. So if somebody wants to unmute themselves and tell me what you think this means, that'd be great. Nobody wants to talk? All right, so I'm noticing that because the confidence intervals overlap, that there probably isn't a significant difference between these two because they do actually overlap. And I know that we've always been told, oh, you can't have, you're supposed to have a difference of means, confidence intervals, but we're finding out these days that really there isn't a lot of difference between having it be that way or not. So that doesn't exactly help us. Confidence intervals also based on the ASA's information is kind of better than a type t-test. So I usually would like to start with this and kind of go through this. And then I can actually do, if I do want to do a t-test, I can show a t-interval. And what this actually is that instead of centering it on 0 like we normally do, we're just going to center it on one of the t's and we're going to subtract the other one. And so looking at this, I see this mean is inside this interval, which it has to be because we're centered on that one. And I notice this means not in that interval. So that kind of tells me, hey, there might be a significance here because this is actually not in here. These confidence intervals look like they overlapped a little bit, but looking at this interval here, instead of it being just centered at 0, like I said, it's centered on your t, one of your t's, it's actually, or one of your means, it actually shows that there's a difference. And there actually is a p-value down here we can actually see. And looking at that p-value, it does look like there is, in fact, significance in this case, if you're using a 0.05 level. And that's kind of what I like to go with and talk about this. One of the other things that we see in a lot of our books is assuming equal variance. That doesn't really get us a whole lot difference. It does in this case a little bit of difference. The significance went away, but actually that assumption of equal variance is not widely used anymore. So we're not going to click on that. We can also take another sample and then we can see, oh, this sample doesn't have significance because now this mean is inside the t interval and we can see that the confidence intervals do in fact overlap. And our p-value is 0.14. So it's just a way to show it. And if you want to take another sample, we can do that. And now you can really see there really doesn't look like there's a difference in this sample. And it shows how samples can make a difference in what's going on. And so I can keep taking more and more samples and I can get my students to realize that there's not much difference. I can also take a bigger sample and then show them how the sample size can actually affect what's going on in our values. So that's what I would do with this, is kind of talk about this. Do you want to look at a difference response variable or explanatory variable? Anybody want to do something different? You all seem to be muted. So I would probably at this point ask my students, what would we like to do different? So maybe we'd go and pick a different piece to look at. Maybe look at weight and diabetes. So that might be interesting. If you have diabetes and you don't have have diabetes, is there a difference between what the weights would be, depending on your diabetes? And so we can see here that my t interval doesn't include this mean. So that does tell me there's significance. And in fact, if you look at the p-value, you can see there is in fact significance here.
Hey, Kate.
Yes.
We have a question from Yelda. Her mic is just a little not working right now. So she asks, do you mainly emphasize the visual or P or both?
I usually emphasize, I actually do both. I like to just have them look at the visual so they get an idea of it. and then bring it to the p-value so we can get a concept of that. But p-values are actually not as accepted as much as it used to be. So I try to get them to really see the visualness of it and what's happening, but the p-value is needed to see the significance of it. So I probably do both. But I probably start with the visual to give them an idea of really what's happening with this. So my students really need to see visualization of it, and then we can talk about this p-value. And that gives us a way to kind of talk about that. And again, I could take another sample and I can see, oh, if I do all these different samples, I don't really see, I do see significance, except this one doesn't have significance. So this is also a way to talk about how different samples will create different values. And then you can talk about, okay, if I have a sample that doesn't show a significance, that doesn't mean there's not one. It just doesn't, it means that that sample didn't show the difference. So it's a good way to actually let them see how your conclusions could change. So I would probably show them a bunch of different samples. And again, this one doesn't show significance, but I can talk about, that doesn't mean there's not a difference. It just means that my sample didn't show it. So it's kind of a nice visual for students to see what's going on. So that's the little t. I'd like to go back to talk about another one we can do. So that's the 2-sample t. So a different app I could do is the proportion little app. So let's go and look at what that one's about. And again, it is under this little app, in the StatPREP menu, it's under little apps, and it's actually says proportions. So there's actually 4 different little apps right now that you can work with. The 2-sample t, the proportion, center and spread, which we already did a webinar on, and the regression and smoothers. So these are all ones that you can use in your class. We pretty much do proportion and t-test together, so I would probably teach both of these around the same time of each other. So I'm going to go into the proportion one. And again, it's very much set up the same way. We would give you the graphic that would have based on my response variable and explanatory variable. And then if we had any covariates, none would be used with this app, but if you had any. And then you have a sample size you can change. So here we're going to look at blood pressure over 130 and whether or not you have poverty. So we had smoke now, but let's look at poverty again. And see, whoops. I don't know why that just happened because it worked just fine the other day. So since that didn't work, we'll go pick a different one. So let's see if you have a different blood pressure and if your blood pressure is affected by you not working or working. So we have, in this case, 3 different things we're looking at in our proportion. We have explanatory variable of you're looking for work, you're working, you're not working, and then you're working. So those are our 3 different things. Again, you can go in the code book to see kind of what those variables mean. This one doesn't have a whole lot of information about those variables, but we can look at those. So we have the not working, and we have the looking. And you can look at see what your blood pressure might be doing based on those. I'll go ahead and take another sample just to see if we see any differences between them. So I am seeing that looking people seem to have lower blood pressure than people who are not working or working. And so again, you can do different samples and take a look at what's happening. And if we wanted to, we can do resampling. And we're going to go ahead and show the 95% confidence interval. So again, noticing this, these confidence intervals all seem to overlap. So that would kind of tell me, oh, there's probably not a difference between blood pressure for people who are working or not working or looking. Again, you can pick different variables here. Let's see if we looked at owning a home and whether or not they work or are looking. Or I personally like being depressed and only know, oh, that one's not working. I don't know why sometimes they don't work. And sometimes they do work. So it just depends. I'll have to talk to the programmer on this and see if he can figure out why sometimes they don't work and sometimes they do.
Kate, we have another question.
Yes.
It's a Yelda asked, in the BP scale, what does yes mean?
Let me go back to the BP scale. So BP scale was BP over 130. So the yes would mean yes, they have a blood pressure over 130, which is considered unsafe. And the no would mean no, they don't have a blood pressure that high. Actually, I'm sorry, this was physical active. So I'm sorry, this was a physical active or not physical active. So the BP is actually on this level, and it is whether or not they have 130 or it's higher than 130. So if it's less than 130 or it is 130 or over. So remember, that's the question we were asked is, are you over 130? So yes would mean yes, you're over 130, and no would mean you're less than 130, or this just is less than 130. And then if you are physical active or not, which I find this very interesting to look at this sample and realizing that between being physical active or not physical active, there doesn't seem to be a difference between what your blood pressure would be. I always found that interesting. Let's look at homeownership again. Homeownership seems to actually make a difference if you actually own a home as opposed to some other things. So the other thing could be that you are homeless, or you are living with somebody or living with your parents. And so that would kind of be interesting. Blood pressure, if you're homeless, I would think you might have a higher blood pressure because you're more worried. And again, you could tell your students, you know, there doesn't seem to be a significance here looking at this information, but it is there to kind of look at. Are there any other questions?
In the chat box.
Huh? So we can pick different things to look at and see, you know, I don't know why some of this is not working and some of it is. So I'm sorry that it's not working today, but like I said, I'll talk to the programmer on this and see what's going on. Again, you can look to see what the ARC commands were that we were using. It is in here that kind of shows you what we typed in, what created the things we were doing, so that you can actually see what's going on. Actually, I would then probably bring my students over to this to show them, because in my class, we actually are using our studio in class, and my students are doing these commands themselves. And then you can see, oh, here's my p-value, and here's my test statistic, and here's what values I'm getting. So it gives them a good chance to see that information. All right, so I'm going to go back into, let's talk about how we assess this. And so this is where I probably would like to have some help from the group as to what you might think. I'm going to tell you what I would do in my classes. And it depends on whether you have an in-class where you have computers available in your class, or you don't have computers. So if you have a classroom, like I have a classroom where I actually have computers, every student has their own computer. I can actually lock down their computers during a test, so I could actually make it to where they could only use our studio on the test. And that way I would know that they're only going to that one place. And so I would actually probably be able to actually let them use our studio, and then probably also give them access to the StatPREP website and ask them to compare, pick two variables to compare and tell me what they can see from it, and come up with a hypothesis and kind of do a conclusion of it, and tell me what confidence interval they get from it. So I'd actually probably have my students go through that in computers. If you don't have computers, you can actually pick which variables you want to look at, and you can actually do screen grabs of the pictures you want and put them on your test, and then ask your students to, based on those screen grabs, to make conclusions from those and do tests. So it's not really having them do the work, it's actually having them interpret, which in reality, interpreting is more important than actually doing a lot of the calculations. So I would probably ask them to do that. I might even give them, if I didn't have computers available, give them several of them and ask them to come up with a conclusion, come up with a hypothesis test based on what they saw. It's a little bit more that way. The other thing you can also do is give a take-home test if your school allows it. My school, I have freedom of academic freedom to where I can do what I want in my classes. So I do give take-home tests. And so I actually give my students things that they have to do at home. Actually, that's not really what I do. I'm going to tell you what I really do is I give my students a project. And so I actually have them come up with their own hypothesis, go and find their own data, collect their own data with a random sample, and then analyze that data in R, giving me both hypothesis tests and confidence intervals. And it's usually a 3-week project that they're working on, that they deal with. I only do it on a t-test with difference of means. I don't want to have them do it on proportions because I like to kind of fill everything in together of making them do make them do a random sample from day 1, have them draw graphs that they need to graph, assess whether it's normal. So basically, it's kind of a capstone project where they're doing things from the whole semester all the way through the whole course. So that's actually what I do in my courses. But there are other options you can do. Like I said, you could do a take-home test if you want. You could do an in-class test where you're giving them the outputs that you want them to work with. Or you could give them, if you have computers available. Does anybody have anything else that they do in their classes?
Well, we do have a few questions, Kate. So the first one is from Susan, and she asks, what are you using to lock down the computers during testing?
So it's my IT department has put something on our computers that allows us to do that. And I'm trying to remember what the program's called. I don't use it very often because I usually actually give take-home tests in my classes. So I probably do a, I can't remember exactly what it's called, but it's through my IT department that actually has done it. So they tell me what I'm using.
All right. And then Jennifer asks, is that project in Stats 1 or Intro to Stats?
It's an Intro to Stats. So it's an Intro Stats course. And I have done this project for years, and my students actually seem to really like it. They complain about the idea of doing this, but I do give them a lot of directions. I give them examples of old projects that were done in my classes in the past. I give them ideas of hypothesis testing, hypothesis they could come up with. I give them ideas of where they could get the data from. And then they can do the project, and they get, like I say, about 3 weeks. And I usually tell them, do not wait till the night before because you won't get it done. I also, because I want to make sure they do understand concepts without having done it that way, I do give an in-class portion of the test, which is just the concept questions. There's no actual calculations done on that test, but I could actually give, and I might actually do it this semester, give some of those some screen grabs from some of these pictures and have them tell me what's happening in this picture, what kind of information could you get from this. So I do give that test also. Are there any other questions? Okay. Does anybody else have any other ideas of how they might do assessment? Oh, and also, I should say, if it's not just testing, you can actually do this with homework problems. So you could actually assign some of these little apps to have your students go to and actually do a homework problem based on it. Give them maybe a little bit more direction than you might on a take-home test, but or on a regular test, but give them the ability to kind of play around with these as a homework. So that's just another suggestion you could do. And I also do a lot of in-class projects to where they work together on things. So they would actually, I could use that as an assessment. So assessments don't always have to be tests and projects. They can also just be in-class things or homework problems. But does anybody have any other ideas for assessing? All right. So we do have time to kind of look at resampling. Again, the resampling tutorials are also on the StatPREP website, so I do want to again show you where those are. They're actually still under resources, so I highly suggest you keep going to the site. We've made some changes recently on the site to give some information. We actually have the dates of next summer's workshops already on here, so you can see exactly what dates we're going to be doing those workshops. We've done some other changes to it. And under resources, under tutorials, these are actually the tutorials we do during our workshops, but we also, and we use them for you to get your own information, to learn about some topics. But like I said, I just used one in my class the other day. So there is actually sampling and resampling. So I'm going to go into first the sampling one just to kind of show you what this is about.
Kate, before you move on, there was one more question about the, I think the assessments. It says, from Yelda, do you ask students to copy the code from little apps and modify them for homework or test?
So I actually don't usually use a little app code. I usually give them the code in class. And we actually spend a lot of time during class going through the codes. And I have lots of videos that I've created that show them how to do things with the codes so that they can look at it afterwards. And so they actually have the codes and I give them all the data for them to put into RStudio. I'm actually going to create a package for RStudio that has all my data in it so they don't have to worry about how to read it in, and it'll all be there for them. But they have different, my students actually are made to go and type their own RS code in, but I give them pretty much everything and tell them exactly what they put in. So it's not where they have to think too much about it, but they have to think a little bit about what they put in. Does that make sense? Okay, so this little, this tutorial is on sampling. And what these are actually little, you actually can go through these different topics. You can read about them. They tell you a little bit more about what it is. This one is going to talk about sampling introduces variability. And so this actually does also have the R code here. So you can actually copy this R code and put it into RStudio. Or you can actually, if you don't have RStudio, you can actually change this code, do what you want to it, and then hit run code and it'll run whatever you type in here. Because this is basically RStudio. This is an RStudio background behind it. You just don't see it. And you can actually change anything you have in here and make a difference. So if I don't want to do a density plot, but I want to do a different type of plot, I can type in what kind of plot I want to do, and it will create it for them. So if you don't have RStudio, and RStudio is available now on the cloud, you can use this instead. My school just created their own RStudio server. So we have our own RStudio server for my college. And my IT department maintains it. It is free as long as we're an educational institution. I just had to put on my syllabus that we would be using RStudio. That proved to RStudio that we are an educational institution using it in class, and we're allowed to have an RStudio server for free. And my IT department was gladly willing to create one. But if you can't get that to happen, you can actually come into these tutorials and then have your students just change what they want in these. And if you click on the run code, it will run it. This is actually a density plot, which I've been using a lot more these days than histograms, though I still use histograms, but I've been using a density plot. And it kind of shows them what is, in fact, for this 10-mile race, what is the density of this data. It actually also calculated the median. So you can see right here, DF stats is gplot command, and I could put in and create this for them. And then I can do other things to see different things that are happening. I can take samples from this data set. I can change how big I want the sample, but let's say I want to take 100 data points. And so I can show my students, hey, look, we can take a sample here and my sample will look different than yours because I can actually have my students in this. And what I do when I want my students in this is I just actually copy the URL up here and paste it into my course management system. so they can click on it and go into it. This will work on any computer, any iPad, or any pad, any surface of any kind. Even your phone. My students can actually do this on their phone in class. And I think the phones are too small to look at, but my students seem to like looking at little tiny phones, and they watch movies, full-length movies on phones. So I think students do a lot of different things these days. So all of this can be done just with a web browser. So if you don't have computers in your classroom, maybe you have iPads on campus that you can take in, or you can have your students bring in their own software. As long as you've got a Wi-Fi, you're good. And so I can actually then show, hey, look, my sample is different. And when I take a different sample, I get in a different one. I also allowed them to see, hey, this is what is called a tidy data, because each column, each row here, each row is a different individual. And I can see I've got different variables for that. I know what state this individual is from. I know what time they started. I know what the net time was. So we talked about actually in class the other day that when you start a race, this race had 10,000 people, I believe, in it. And you can't start all 10,000 people at the exact same time. So the time is actually what time they actually finished, but the net time is actually how long it took them to really run the race. So that is a little bit more information for them. And so I talk about what net really is their real time to run the race. Then you've got their age and their sex. And so this is tidy data because each row is a different individual and you have the same information for that. And I can keep taking random samples and show them how the samples are different. This one here will also take a random sample. And if I wanted to, I could change to what size. So I might actually change this to only 10 people and then run it so that we can just look at those 10 people, and then somebody else can do 10 people and we can show, hey, yeah, they're all different. They're all going to be the same sample. And then here, if I do this one, I might, again, I might take this one, it'll take a random sample and it'll then calculate the median for it. And I can see from my sample what is the median here that was created. And then this is kind of nice for your learning thing, and even for your students, is it actually can ask questions and have you try different things. So you could put in what you want your sample size to be here and what you want to maybe calculate. So if you're going to do based on age, you might want to calculate, let's say, the mean. I can type in mean in here. And then I can maybe take a sample of size 100. And I can find out what the mean age was for my sample. And it gives you the printout here and tells you the mean age. And then if we go to the next topic, and all this just means is the next page. You can do different things with this and collect information and show how your sizes get different and how when you take different samples, you get different values. So if we were to run this code, I can see I've taken different samples here and how my means are not the same, or my medians in this case. And I can do the same thing here where I can actually take different samples, different size samples, and I'm going to take samples over and over and over again. And then I'm going to do a density plot of those samples. And yeah, you can see I took a sample of size 100, I did it 200 times, and I calculated the mean each time, actually the median each time. And then, hey, I actually have a sampling distribution of my median. And we actually did this in class the other day where I showed them my sampling distribution of my median. And then what shape did we get here? And so I actually changed the sample down to like 10 and had them run the code. And we could see, wow, that doesn't look very normal. But when we got up to about 30, I got a more normal base shapes thing going on. So it just is a nice way to kind of introduce the idea of a sampling distribution and the central limit theorem. So we'll go back to 100, and you can really see that when you increase your sample size, you get a very nice looking normal shape. And you can also see what happened to the standard deviation, and that's how I actually was able to explain to my students why the median or the mean didn't change. The mean of the sample is the same as the mean of the population, but my standard deviation for my sample the standard deviation of my sample mean got smaller and smaller based on that square root of n. And I actually had my students calculate that, and we saw, hey, that was pretty close to what number we're seeing here. So it's kind of a nice way to see that. And again, you can ask a question to see kind of what's going on. And have your students kind of do a little quick assessment in class to see what kind of answers they get and see how many got the right answer. And then again, you can look at making your own sample size and how that changes. So I did it on the previous page, but you can do it on this page here instead and take a look at that. And again, if you don't want a density plot, you can change this. Let's say we want to do a dot plot. I can change density to dot plot and put that in there, and then I get a dot plot instead. Let's say I do 10, and I'm going to go ahead and run this code. Oops. Did something wrong? I must have typed in something wrong. I'll have to look at what that was, but I just, oh, I know what it is. I didn't take these parentheses out. There we go. All right, now let's run this. And there's my little dot plot, and you can see what's going on. If you can increase the sample size, you can see your dot plot becomes more and more normal shaped. So let's go to up to 100 and see what we get. And there's your dot plot's a little different. So just as a way to kind of show it, if you don't like density plots, you can change this to even a histogram if you prefer a histogram. And then I'm going to run that code. And again, you can see your nice bell shape kind of going up. You got this little ish thing here, but usually you get a nice little shape going on. So it's just a way to kind of look at this information and see what happens. And you can talk about, again, doing some exercises in class, having the students put in make these changes that they want to make and do these calculations themselves and see what goes on and see what changes they get. And I didn't have my students do that the other day because we were running out of time in class, but it would be a way for them to kind of play around a little bit more with it in class. Again, this can all be done with a browser, and so can RStudio nowadays. And then the last thing just kind of gives you a little note about what's going on and kind of some different things you can try. So that's that little app. Sorry, that's that tutorial. I want to go back to the other tutorial, the resampling one. And this I actually did use in my class the other day, and actually I used the shuffle one in my class the other day. So this is resampling, is also one you can use, and you talk about how Fisher really wanted us to use resampling and not the assumption tests that we use these days, but he couldn't because we didn't have the computing power. But since we now have the computing power, we can now do it. And you can see kind of what's going on with this and make these changes. It looks like I actually ran this already. So if you have it to where it's already done the calculations for you and want to start over, you can actually click this little button that says start over. And it'll start everything over and reset everything for you. And so we did that. And now we can start going into it and kind of see what's going on with variation. Run this and we can see here's what our data set actually looks like. So this is what I'm sorry, not data set, this is the population, and what the population actually looks like for this data and what its mean or median actually is. And then you can actually take samples from this and see what kind of sample you could get of size 100. And again, this gets to talk about tidy data here. And then you could actually do, again, a sample again and calculate the median. And you can talk about, hey, look, my median isn't that far off from the population median. It's not exactly the same, but it's not that far off. And that's a good way to talk about how your samples can be different than your populations. And if you run the code again, it will take a different sample. And you can show, hey, this sample had a different median than the other sample had. So those are just really good explanations of that. And then we can run through and do, oh, I had to make some changes here. I didn't make them. And go through this. And this gives you an idea of what is resampling. And resampling is where you take, we'll run this code here. And it's where it takes a sample, calculates the median, and then takes another sample from that same 10 data sets that we had, and keeps doing this over and over and over again. and you can see what the differences would be. And so I kind of like this one also because it gives you an idea of what's happening. You do each trial, you do it 200 times, and you're going to calculate the median every single time of every single sample you took from this data set. Resampling is done with replacement, so we can even do it for small sample sizes and so forth. So it's kind of a nice piece of showing students of what's going on. All right, so now I'm trying to get back out of here.
All right, we have one more question. Is tidying the data something you also include in your R tutorials? This is from Yelda.
I don't actually include it in my R tutorials. I don't actually have them do it in R, but I do talk about the idea of tidying data like basically the second day. Because the first day of my class, I had my students take a survey for me. And then we look at that survey and I go, well, you know, we need to now, looking at the survey, we have some tidying we need to do because we have some cleaning we need to do. And so we talk about that cleaning and what needs to happen. And more things like somebody typed in that their car was a Honda with a capital H and somebody did it with a small h. I also did a thing where I had students throw a ball around the room, a globe around the room, and see if they landed on water or on land. And then I had them type in yes or no. And some of them put yes with a capital Y and some put yes with a small y. So we had to talk about cleaning that data. So second day I talk about cleaning it, but I don't spend a lot of time on cleaning. Are there any other questions? I'm kind of at that point. So do you have any other questions you'd like to ask? And like I said, I actually did the shuffle one the other day where I actually had the students and I made cards up with, some of them are yellow and some of them are blue with the different data sets from the shuffling tutorial. And I then had my students shuffle the cards and take samples by putting the cards in two different things and calculate the mean from each one. And then we could talk about, we were doing resampling methods and how that worked. And that's how I introduced hypothesis testing actually in my class the other day. We have to do a little bit more formalization of it on Monday, but that's how we started talking about hypothesis testing and doing that with doing resampling methods instead of going traditionally with just a regular z-test or t-test. So it's kind of a nice way to introduce it. So are there any other questions you'd like to ask?
All right, Yelda asks, are the videos you mentioned earlier or some of it posted in YouTube?
So I actually have posted all of my videos on my YouTube channel. I don't remember what my YouTube channel is called, but it is, I believe it's my name, Kate Kozak and Statistics. So I think that's what mine is. I could actually, if you email me, I could post that. I could send you my YouTube channel that you could then find that information. These are all videos that I've just created in my office. So they're not like beautiful videos, but they work for my students. And Stephanie, are you putting my?
Yeah, I'm about to post your email address in the chat box now.
Thank you.
But no problem.
I should have put that on one of the slides. I'll have to do that in the future. Are there any other questions? Okay, I'm not hearing any. I will gladly always answer questions.
There's one more.
Oh, there isn't one more. Okay, perfect.
Yeah, she can't speak, so sometimes it takes a second to pop up. But Yelda asks, what is the prerequisite for your stat class?
So my statistics course has a prerequisite of either college algebra or college mathematics, which is quantitative reasoning. So they can either take a quantitative reasoning course to get into my stats course, or college algebra to get into my stats course, or pre-calculus. And I do have a variety of students in my classes. Some of them have just come straight out of our quantitative reasoning course. Some of them have come out of, which actually has statistics in it and probability in it. The students who come straight out of college algebra most likely have not seen any statistics yet. And so we do have to spend a little more time on the descriptive statistics at the beginning than I'd like to, and a little bit more probability than I'd like to. And the pre-calc students are usually catch on pretty fast because they're pre-calculus students. But my course is also a little different. We have a math stats course here at the college. We have a psych stats course here at the college, and we have a business stats course here at the college. And we've decided a while ago, we started offering the math stats class and the business stats class co-listed together. So the students in the class could be math stats students, which are usually nursing students, or I've had some construction students in that class. I've had biology students in that class. I've had other science students in that class, or they could be business students in that course. And so that's where we get kind of a variety of knowledge levels in there. Most of our business students have had college algebra because they need to go on to calc, to business calc. Any other questions? So there will be a link in the chat room for the SurveyMonkey survey. If you could please do that survey, we'd really appreciate it. Any input is always good for us. If there's no other questions, we can wait a couple of seconds, see if there's any more.
Yoda said thank you for the talk and answering all her questions.
You're so welcome, anytime. If anybody doesn't have any other questions, we can go ahead. This will get posted. The recording of this webinar will get posted on the StatPREP website, maybe by early next week. If you have any other questions, please feel free to always email me. I will gladly always answer emails for people. That's my job, is to answer questions, because we're all teachers, so we all like to answer questions. And I gladly answer any questions you have.